Welcome, everybody. Thanks for joining us today. We're just going to give it a few moments and let some people file in here before we get started. Give everybody just a few seconds to join up here. All right, that number keeps going up. We're about a minute in, so we're going to go ahead and get started. First of all, welcome everyone to our virtual training session, and thank you for joining us. For the next hour or so, we'll be talking about CAD data access and mesh processing using HOOPS Exchange and Polygonica. I'm Robert Beyer with TechSoft 3D, and I'll be your host today. But the real reason I'm here is to introduce you to our presenters, and we have some good ones for you today. Starting off with Peter Kane, he's our consulting engineer here at TechSoft 3D, followed by Toby Hazel, consulting engineer with Polygonica, and Richard Aidley, consulting engineer also with Polygonica. So thanks for being here with us today, guys. And with that, I'll go ahead and pass it off to Peter. Pete, take it away.
Well, thank you very much, Robert, and welcome to those of you who've joined the session, and thanks for Tony and Rich as well. So this is quite a focused presentation that's concentrating on the HOOPS Exchange Polygonica Bridge. We'll start by, I'll give you a little bit of background in Exchange. We'll follow that with some background in Polygonica, a discussion on the bridge, why it's needed, and a demo by Toby. We'll show you some source code. And then finally, we'll just wrap up with how you can get hold of it and how you can use it yourselves. We're not going to go into a lot of detail on Exchange and Polygonica. That's been covered in other sessions, but for those of you who are not that familiar with either of them, we'll just cover some of the basics. So, HOOPS Exchange is a CAD data toolkit, an SDK with a C++ interface that supports the import of over 30 different CAD formats. And one of the principal pieces of data that it imports from CAD files is the BREP, the boundary representation that represents the geometry and topology of the models. And we import all those different representations into, as you can see here, from various different CAD formats. We cover all the major CAD formats. We're what you would call reverse engineer. You don't need to get a copy of these CAD systems yourselves. We can read the data by reverse engineering the formats. We also support some open standards as well, such as STEP, GLTF, and so forth. Now, the important thing about working with all these different formats is that we import them all into one data model, which we call PRC. PRC is compact product representation. It happens to be an ISO standard, and it's also the basis for 3D model representation in the 3D content in a PDF file as well. With regard to this call, the important type of data that it imports is the model tree or the product structure, the boundary rep, and it can also import mesh data as well. In addition to that, it can import color information, product manufacturing information, view data as well, and also it can also import user data as well. That's kind of typical name value pairs containing information that the end user might, or the application might have attached to the original model. So if you're starting with a CAD model, we import this CAD model into this PRC format, and we represent this hierarchical product structure, the assembly structure you get in many mechanical designs. How we represent that in terms of the PRC data model is that we have this notion of a product occurrence. A product occurrence is essentially an assembly node, and this is hierarchical. You can have product occurrences that reference other product occurrences, and so represent a kind of complex assembly structure. The part, as the name implies, we've got a part definition, which represents, if you like, a single part, typically in a CAD file, and that part in turn is represented by something we call a representation item. So we're starting with a model file. We have a hierarchy of assembly nodes, which we call product occurrences. These product occurrences give this structure of the CAD file, and then we get down to an individual part definition. That individual part definition may have more than one representation. For instance, if you were to work with SolidWorks, you would find that if you imported a part, there's two representations of that SolidWorks file. There's an exact geometry, the boundary rep, and there's also tessellated data as well. And when we import these CAD files into HOOPS Exchange, into the PLC data model, we can also hold this information as well. This BREP model highlighted here, the exact BREP geometry, and also the tessellated geometry as well. But these not all CAD files have this tessellated data. In fact, some formats, of course, are just tessellation, but for this presentation, we'll stick to BREP-based models. And if we don't have the tessellation, HOOPS Exchange, as part of its toolkit, it's got the capability to generate tessellation, that is triangulation of this exact geometry. And there are various different controls and algorithms within the HOOPS Exchange package that allows you to generate tessellated data from the exact geometry. And it's this tessellated data that forms the basis of the bridge to Polygonica. Just a little more on when I talk about BREP data and exact data, the topological structure of that data is shown here. And without going into too much detail, I think the important parts of that structure that are relevant today are the fact that a solid might be divided into individual faces. In this case, it's a cube with 6 faces here, but in practice, for more complex objects, you're going to get faces made out of different geometries, cylinders, NURB surfaces, and so forth. Typically, for workflows, a user will be interacting with the faces. If it's a CAE workflow, you might be putting boundary conditions on the face. Sometimes, therefore, this is a type of data that you want to preserve when you have a workflow that involves both Exchange and Polygonica. Now, to hand over to Rich at this point, he's going to go into a bit more detail about Polygonica and the Polygonica bridge.
Hi, everybody. Thanks, Peter. So I'm going to just talk very quickly about Polygonica because I believe everyone on this call already knows what it is. So this is really for the benefit of people who are watching the recording later. But Polygonica is a mesh modeling toolkit. We provide it as an SDK. So our users are providing software to end users. We don't provide anything that end users can use themselves. So it's spun off from MachineWorks in about 2013. MachineWorks obviously is our CNC product that's been going for about 30 years now. So most of the Polygonica clients are in CAD or CAM or CAE fields, also additive manufacturing, BIM, dental, scan registration, and confirming manufacturing details, so like uses in factories. Polygonica, again, I'm just going to go quickly over these capabilities. We can heal models, so this is Typically, if you've got scan data and that scan data has problems, or you have operations upstream which have introduced, say, non-manifold edges or self-intersections and so on, then we have ways of fixing those effectively and quickly. Then we provide a lot of capabilities for additive manufacturing or preparing to additive manufacturing. So in this case, things like creating lattices for solids or tracking deformations. So if you've got a 3D printing process where the heat or weight of your object is bending it, we can compensate for that before it goes through to the printer. Similarly, there is remeshing, so changing the quality of the tessellations for whatever reason. We have plenty of 2D capability, which is often overlooked. So this is things like 2D profiles or medial axis. Again, we have a 2D Boolean engine of a similar level of complexity to our 3D Boolean engine. We can do a lot with point clouds. This was typically scan data or LiDAR information, which is much the same thing. So we can register point clouds, we can triangulate them so we can turn them back into solid objects, and so on. We can do a lot of mesh analysis. Now, when I say analysis, I'm talking about geometric features. So this is things like thickness or gap detection, or looking for things which might be CAD surfaces within a scanned object, as opposed to, say, material analysis. So in other words, we're not doing material analysis, we're just doing the geometric analysis. Obviously, we have Boolean operations. That's kind of our core thing. This is what came out of MachineWorks. So we've got very fast and very accurate 3D Boolean operations, which kind of, because this software is built up over 30 years, because it's based on the underlying MachineWorks, this will handle a really large number of kind of very tricky corner cases that you might otherwise have problems with. And lastly, on these slides, we have mesh creation and alteration. Nobody's expecting to make a modeling program with Polygonica, but you might well be adapting things which you've loaded in. So, for example, sweeping profiles or adding text to things via embossing and so on. So it's got the capability to adjust what you've brought in. So that's kind of Polygonica's capabilities and use cases. This is a big list you can go back and look at later if you like. But this is kind of this is where the bridge comes in. So this is the internal representation, the way that Polygonica sees the world. Kind of right in the middle of this diagram, we have the PT solid, which is essentially your model. So that's one 3D model. It can be made up of multiple shells, for example. If you've got multiple models in your world or your scene, each element in that scene is a PT world entity, which will be connected to a different PT solid. So if you've got, say, an assembly with those of bolts the same, then each of those bolts would be a different world entity, but they would all be connected to the same PT solid. So the world entity has location and transformation information on it. And the PT solid has what you would think of as model data on it. So it's kind of your library. If you're wondering why everything's called PT, obviously that just stands for Polygonica type, because we're quite old school. And the PT solid is made up of PT faces. Faces mean different things to different people. To us, if we're talking about faces, we're talking about triangles. You know, it's a triangle engine. The triangle will have its own properties, you know, to do with its position, its normals, and so on. It also carries this element called the PT app surface, which will connect it back to the surface in the original CAD object, or can be used to connect it back to the surface in the original CAD object. The other thing I've put on here is the PT entity list. This is just an idea that collects large numbers of faces together. It's a useful concept when you're doing operations with things and you're asking for, say, regions on surfaces and that kind of thing. What you'll notice that Polygonica doesn't have here is any kind of hierarchy in the PT world entities. They're a flat structure. They're all at the same level. You can't put a PT world entity under another PT world entity. So unlike HOOPS Exchange, it has no kind of tree way inherently of organizing the data that's come into it. Which brings us handily to what is the Polygonica Exchange Bridge for? So for Polygonica users, it then provides things which Polygonica's kind of core competencies doesn't. So Polygonica, for example, can only load 2 file types. We have our own proprietary Polygonica one, and we can load STL file types, and that's pretty much it. Whereas you've already seen the huge list that Peter gave us that HOOPS Exchange can bring in. Then, as I've just mentioned, the PT world entity hierarchy is flat. So the HOOPS Exchange then provides a way for us to put that into a tree structure, which is going to be important if you're, for example, doing, well, anything which requires that. If you're doing like buildings and they've got things inside them, rooms, desks, electrics, components like that, where you want to be able to tunnel all the way down through a tree view. Lastly, HOOPS Exchange provides access to attributes on CAD data, which is pretty important because this stuff's obviously stored very differently in different file formats. So the fact that HOOPS Exchange gives us a common way of finding that is really valuable. So if you're including the Exchange Bridge inside your own application, this is kind of how it would work. So the Exchange Bridge, I don't think we've mentioned yet, is a header-only file. So it's a C header file, Exchange Polygonica Bridge.h. And that would go, we'd include that inside your own code. So that's then going to be the thing which communicates with your application logic. You would include Polygonica as a library within your application, and the Exchange Bridge will communicate with that, and obviously your own app data will communicate with it. And then HOOPS Exchange will load itself as a library from the header. So it's the HOOPS Exchange then brings the data in from the CAD file, and then via the bridge, it ends up in Polygonica, where you can make use of it from your application. And the way that this mapping happens is, so there's a very simple call, this A3D model create PG world, which is a function that's in the header. And you pass to it this A3D Polygonica options, which is the middle one of those parameters. And you pass in the world, the PT world that you've created from Polygonica for it to be filled in, and you'll get out a list of parts, where those parts are, and the surfaces, and so on. So we can see here in the mapping, we've got, so part models in the HOOPS Exchange are going to be these A3D ASM part definition objects, and they'll be mapped to PT solids in Polygonica. But what we get out is a PT world entity, which will have as its child one of these solids. If there's instancing going on, I'll go back to my bolt example. If you've got an object with lots of identical bolts in it, each of those bolts will be a different world entity. They'll all come out on the same PT solid. And so this is going to be communicated through this M_entities field of the options, which is just a map of the world entities from which you can get the PT solids. Then we've got this idea of surfaces. So original surfaces on the CAD models. In fact, we can get these out in 2 different ways into the application. The first is that we're providing a map of them for each solid. We have a vector of entity groups, which are very much like the entity lists that I was just talking about. So that'll be, this solid has all of these different sets of faces on it. So each of those entity groups will be a set of triangles which represents one original CAD surface. But also, you can also use this PT app surface, which is a property which is set on each individual triangle, when it comes back out into Polygonica. So it kind of depends what your use case is, which one of those routes you would want to take to get that information. Then, of course, we have the assembly path that we were talking about. And this is going to map each world entity to a vector. Now, it says a void star here, but these are all A3D, I forget exactly, whichever the child object, maybe Peter can tell us, child object is of A3D, ASM part definition, and ASM part product occurrence. That's what this chain of objects will be, and it'll take you from the top of the tree down to the leaf node, which is the one that corresponds to this particular world entity, and that's what the map is for. The material colors is not particularly important. That's created as a byproduct because when objects come in and they have colors on the surfaces, we're transforming those into Polygonica materials, in this case render styles, and that's just a map for that. So we've done quite a lot of just talking. It's maybe a good time to show you something. So I'm going to hand over to Toby, and he'll give you a demonstration of how this works in practice.
Great, thanks, Rich. I'll just see if I can share my screen here. Right. Okay. Yes. So as part of some recent changes to the bridge, we've written an example to demonstrate the usage of the code and usage of the data once you've loaded into Polygonica. This is written in C++ and has a number of simple steps. So here it is. So first of all, we load a model. It takes about 10 seconds. So here we'll be loading a CATIA part. It's a water bottle that comes as one of the samples with HOOPS Exchange. Yeah. So there are two modes that you can run the example in. And the first, the one that we're using here, all of the solids are combined into a single solid. And in the second one, all of the solids and world entities are used as they come out of the bridge. As Rich pointed out, Polygonica has a flat structure, so there's no tree structure. So how we handle instancing is using world entities. So you might have a single part that has a solid and multiple instances, which are multiple world entities within the scene. But we're just using a single solid here. So the first thing that we do, having loaded it, is we'll use Polygonica's API to heal the solid, which takes just about 6 seconds. So here it is. It's the same solid, but this is healed. So we can be sure that we have no self-intersections. It's a single shell. So the next step, we're going to show all of the CAD surface patches. So here we've colored all of the faces on the solid to demonstrate the CAD faces, CAD surface patches. So each individual colored patch here is one CAD surface. And we've done this by using the PT app surface data, which Rich mentioned earlier. This is an addition to Polygonica in 3.2. These are set on loading through the bridge to indicate the CAD surface patches, and they're set on each of the Polygonica faces. When I say a Polygonica face, I mean an individual polygon within the mesh. So next we'll just show the edges here. So we can see the individual polygons within the mesh. And you can see you get a nice straight line edge down the boundary of this patch here. So the next thing we'll do is remesh using Polygonica's remeshing API. So we'll be remeshing here using a maximum error. So a maximum distance between the original geometry loaded from the model and the geometry in the remesh version. But also we'll be specifying that the remesh should maintain the CAD patch boundaries. So all the boundaries between these colored areas, they will be preserved in this remesh. We'll just wait for that to finish. It should take 30 or 40 seconds to remesh. Here we go. So here we have our remeshed version. And we can see that the colored patches have stayed the same. So we still have these same PT app surface data defined CAD patches available to us having loaded through the bridge. So I'm just going to hide all of that edge and color data now. So we've just got a plain gray model and demonstrate how we can use this app surface data. So as well as being able to use it in the remesh, it's available to us. So I've double clicked a face here and highlighted an entire CAD surface patch here in green. And this is done by selecting all of the polygons within the mesh that share the same PT app surface value as the one clicked. And this just makes it very easy to select an individual CAD surface or CAD face on this model, even though we have remeshed it, having loaded through the bridge. Okay, and that's the end of the example. So I think I'm now going to hand back to Peter, who will take us through a walkthrough of a very similar example, so we can have a look at the actual code for this.
Great. Okay, thank you very much, Toby. So let me just share my screen. Yeah, as Toby just said, we've got there's another simple example that comes with the bridge. We'll mention later on how you can get hold of this. This code sample translates to PG solids. I'll just run it first, and then you can see it's going to load a model. It's also a CATIA model, but there's no significance to the fact that they're both CATIA. And as you can see, this is also a demo model that comes with the HOOPS Exchange toolkit. And if I to double click on a particular part, you can see that we've got the mesh in Polygonica that represents a particular CAD surface as well. In this case, for this example, we're not doing any operations beyond simply identifying the faces. Just one thing to show you, you can see when I imported this as well, we're just printing out the paths that Rich mentioned earlier about this mapping between the hierarchical structure that you might have in a CAD file, and the fact that Polygonica only has this much flatter structure with the concept of a world entity with a transform, whereas we've got this whole series of transforms that go down the structure. So I think if I were to, let me see if I've got the aqua bottle here, but this shows you the kind of structure you get using our HOOPS demo viewer. You can see down here the attached. We've got these different nodes that represent parts of this assembly, and there will be different transforms attached to different parts of the assembly as well. So we've got this hierarchy in HOOPS Exchange, and we have to translate that to a series of paths that represent that in Polygonica. So how just to go through this really simple example, how does that happen? Well, first of all, you can see we're including this Exchange bridge. Then we have to include the HOOPS Exchange API and the Polygonica header files as well. If we go down to the basic program here, there's very few lines of code. There's more code setting up paths than there are actually doing the conversion. So you can see fundamentally we've got this HOOPS Exchange loader where we're given the paths to the location of where the HOOPS Exchange libraries are. We've got some initialization of the Polygonica, for instance, providing the license, and the rest is setting up error callbacks, this PG window crate and so forth. This is just so we can have some basic graphics in this demo. But if you wanted to do a command line program that just took in an exchange model and converted it to a Polygonica model with some operations like meshing or remeshing or something, you wouldn't, or you're integrating it into your own user interface framework, you wouldn't need any of this PG window crate or so forth. So essentially, you initialize Exchange, you initialize Polygonica, and then the kind of meat of this is you import the file into Polygonica using this the loader and the import command. From that, you've got a HOOPS Exchange model from the loader, providing it's been successful, of course. And you call this function that Rich talked about, A3D model create PG world, and that's it. At this point, you've imported a CAD model and you've created a Polygonica representation of that. And so what this example really demonstrates is the associativity as well. And if we just get down to, here's some code, for instance, down here, we showed those paths, this notion of this PG options, this structure here that has the mapping between each instance of a part in HOOPS Exchange and the representation of that part in Polygonica. So this code here is just looping through this mapping table here and printing out, in this case, it's just giving you this list of product occurrences that lead down to the leaf node that represents an individual instance of a part. Then when we were discussing how do you this property that you can associate with there's two notions of faces here, of course. There's what we call a face in HOOPS Exchange, which is the top BREP topological face, and then you've got a PT face in Polygonica, which is a triangle in the Polygonica mesh representation. So in the example I just showed you, we're just using the Polygonica pick functions, and we're using that to get a face. And this face, we've got an entity group of faces here. We take one face, a PT face, and using that PT face, we can find the solid that is associated with it. And then what we're interested in is getting this group of all of the PT faces, all these other triangles that map onto the original CAD face. And to do that, if we just go up to this function at the top here, find region from app data, you can see here we've got this PT prop app surface. Now you'll notice I've commented some code out, and I've deliberately left that in. For those of you who've used the older version of the bridge, there have been one or two changes that have been made. In particular, as Rich and Toby have said, they kind of rethought through how they're holding this data inside Polygonica. So instead of using this general property for associating any kind of application data with a face, they've now introduced this app surface property, which is specifically to handle this case of associating CAD faces with Polygonica faces. So this is this is really and in this case, as Rich mentioned, it's been cast from a void pointer, but in fact, you could use that void pointer to cast back to the original data that's in HOOPS Exchange as well. So, I mean, that's essentially, we're going to post this updated example on GitHub along with the source code for the Polygonica Bridge. And just to give you an idea of what the Polygonica Bridge is doing, very, very briefly, you can see that at the top level, we've got this model create PG world, which is a function you would call in your application. And then essentially, if you remember earlier, I showed a diagram with at the top we had a model, then under that we'd have product occurrences, then part definitions, and ultimately we'd be going down to the representation item. So what the code in this header file is doing, it's simply walking down that product structure. So you can see here at the top level from the model file, we get the product occurrences. We walk down this hierarchy of product occurrences, and an important part of the product occurrence, of course, is the local transform that's associated with that product occurrence that positions the part or a subassembly with reference to its parent. And so as this code walks down the tree, it's building up this set of transforms which ultimately are going to get applied to the PT world entity. And so we're dealing with these, as I say, product occurrences, and ultimately we will get down to a part definition. And if we just go down to that, you can see when we get down to the part definition, I mentioned representation items, which in this case, we're interested in one particular type of representation item. We're interested in getting hold of the tessellation that's associated with this part, and in turn, ultimately, we then create from the representation item, we create a PT solid. Remember, a PT solid. The difference between a PT solid and world entity is the solid represents, if you like, the part, whereas a world entity represents instances of that part with associated transform. So that's essentially what we've got. There's a very simple example. You've got the code, it manually traverses the assembly and product structure of a HOOPS Exchange model, and then maps it over to a Polygonica model. Now I'm going to hand back to Rich at this stage to finish off.
Cool, thanks, Peter. All right. So, all right, you can see my screen. There's not much left to say, really. This is where you can find it. It's freshly on GitHub. It was on Bitbucket. Yeah. Then there's, so this is kind of almost a recap of what Peter was just saying, but if you're trying to get it into your C++, then you'll need to add the bridge. You'll need to add the Polygonica, the pg.lib library, unless you're using Polygonica's inbuilt rendering, in which case you'll use the pg.ogl library instead for the OpenGL rendering. And then obviously the HOOPS Exchange will kind of load itself. So the Exchange Polygonica Bridge will load the DLL, so you don't need to include the HOOPS DLL directly into your project. If you're trying to do it on C#, it's going to be a little bit more complicated. That's why it says still experimental at the top of here. Because the bridge is a C header, obviously you can't include it directly in C#. So the approach that we've taken is to have a C++ CLI layer that essentially wraps that header file. It's very thin, just so the C# can call it, and it'll export the stuff back. it does mean that because the managed and the unmanaged will both be linking to Polygonica, it requires a dynamically linked Polygonica library, whereas we normally provide a static one. So this is something that you want to try out. You will need to come to the Polygonica CE team and ask for it. That's it really. So I think we can move on to questions now.
Yeah, that's great. Thank you, Peter, Toby, Rich, for the presentations. That was really, really great. As Rich said, is there any questions that we can answer? We have 3 experts in the house right now who would be happy to field some questions for you. So if there's anything you have, feel free to go ahead and put it into either the question box at the bottom of the screen or into the chat. We'll give you just a few seconds to get those in there if you have them. Just wait a bit. I'd hate to cut anyone off who's in the process of typing out a question. In the meantime, is there any additional information we can share? We've said where we can find it on GitHub. You can find more information either at textopview.com or on polygonica.com.
Yeah, just one thing. If you are going to pull it down, you're welcome to pull it the header file down today. It's fine. We're not going to change that. We will be uploading a new version of Translate to PG Solid sample as well. So that's probably going to go up tomorrow, I would think, or later today.
Great, thanks for that, Pete. We did have a question come in from Justin. It looks like I see on GitHub the textures are not currently supported. Is that up to date? And if so, when is support planned for textures? Any idea on that?
That's a good question. This bridge, as you see, it's not part of the product. It's developed outside the product. So we don't have a hard schedule about when we're going to add specific features to that, but it's a little demand driven. I know in the past when we've Rich, Polygonica can handle the preservation of UV coordinates when it does meshing as well. So obviously a prerequisite when we're talking about handling texturing, we're really talking about handling UV coordinates or texture coordinates in this case, rather than transferring the textures themselves to Polygonica. So in the past, we've had we to give you some background. Myself and Toby, Rich, and other staff at Texoff 3D. There's probably about 3 or 4 different variants of interfaces between Exchange and Polygonica. We've all written in the past or modified going around, and at least one of those versions did handle texture coordinates. If the bridge at the moment hasn't handling texture coordinates, I'm sure it's not going to be a massive task for us to take that and add it to the bridge in future. So I guess I hadn't really thought about how we're going to handle this going forward, but maybe we somehow need a kind of forum for requests for additions to the bridge. Rich, a lot of the original work was done by Jonathan. Our company's now moved into a more, let's say, management role rather than frontline technical. And then Rich and Toby have done quite a lot of work at MachineWorks recently, particularly with the modifications to the way the mapping is handled. So I guess it's going to be between us and whoever else in our company wants to throw a chip in going forward. So I've not really answered your question when we're going to do it, but I guess now it's been brought to our attention. If we're going to prioritize things, that's an obvious thing.
Yeah, Pete, as you mentioned, we do have a community forum. It might be a good place for something like this to live, where we can talk
Good
about
point. Yeah.
future options for support, or where
Do
interest.
do we have a Polygonica part of the forum? I can't remember. If not, I mean,
Yeah, I actually don't know. If we don't, we'll definitely get that sorted, and yeah, I think that's a good place to kind of seek out information on the bridge for the time being. Is we'll build out a section in our forum where we can kind of support questions geared towards that. All right.
are there any? I'd be interested if anyone's got any of the features they want or particular workflows they want to. They think it's important for the bridge to support. I mean, when we've been doing the work, we've been trying to think of certain workflows. Now, there's some workflows where mostly you're working with individual parts where the product structure doesn't matter so much. In CA workflows, you're interested in preserving the faces, that maybe the boundary conditions have been associated. And I know Rich has been working on assembly structures, particularly in BIM. If there's particular workflows anyone really wants to use a bridge for, I know of, let us know.
Yeah, absolutely. And I just put a link to our forum into the chat. It's forum.techsoft3d.com. There's not a section built out for the bridge yet, but that's something we'll sort out. And all right, well, we have one more question come in here. Let's see. So with the bridge, I can get the part from Exchange to Polygonica. Is there also code to get it back to Exchange or into Visualize?
Okay, that's a good question. Now, I mentioned that there were various versions of Polygonica to Exchange and bridges around in our company, and at least one of them did that. I mean, what is the answer right now is no. If it depends how deep you want to get into Exchange programming, but essentially, earlier on I mentioned that I showed we've got these representation items that a part definition can represent, and you could, in theory, take the mesh that you've taken from Polygonica, and you could then replace the representation item, I guess, that represented that in Exchange. I'm sure. I think if you were only interested in the individual part, it won't be too bad. I'm not sure because I haven't implemented this. I think you might have to go into a bit more detail to preserve the face structure that you could do. But yeah, we haven't got it, but it could be done if it was desirable. But most of the workflows we've got are kind of going one way, downstream operations using Polygonica at the moment. I mean, Rich, I think you were looking at clash detection in BIM models at one point. So
yeah, that's right. But there wasn't a plan to export them back again.
But where you could make use of that is that if you used Polygonica for efficient clash detection of a model, you would know what the original parts were in Exchange that had clashed, and and you could kind of flag that back to your application and say, highlight input. Now going to Visualize, I think you've looked at this after you looking at taking, and we will have code that goes from Polygonica to Visualize somewhere, but if any,
I know it was on our list of things to look into, but I don't think we've done it as yet.
Okay. Yeah, I may have some code hanging around somewhere that does that, but it's it should be relatively straightforward to do that. It depends on how complex your Visualize application is.
So just remind me, is HOOPS Visualize, is that the web-based one?
No, that's communicator.
Sorry. Yeah, we have used Hoops Visualize for it.
Yeah, there is also code around that does do Polygonica to communicator as well. If someone was interested in that.
Yeah.
Okay. Great. Yeah, great question, Tobias. Thank you for that. Well, there's no more questions currently in our queue, so I think we can go ahead and safely wrap it up. But thank you everyone for joining us. Thanks again to the presenters. If you do come up with questions, I encourage you to head over to the forum there at forum.texsofttheater.com, and we can get in touch that way. But thanks again, everyone. This recording will be made available to everyone who registered, so we'll send that out in the next few days. But thanks for joining us, and have a great rest of your day.